Hello and welcome to this section of the Algebra Tutor. In this section we're going to continue building our foundations of all the important concepts in algebra. And this time we're going to talk about the properties of real numbers. So we're building that foundational material that's going to help us go on and solve equations and do all the other things that we're going to get to in algebra very, very soon. So in this section what we're really going to do is talk about numbers a little bit. And what I mean by that is there are several properties that you can write down that apply to real numbers. Now don't forget, when we talk about real numbers, it just means that the number is not imaginary. And you may have heard of that if you haven't gotten to imaginary numbers in your math training yet. Imaginary numbers are something that you'll deal with a little bit later on. But there's two broad classes of numbers. The real numbers, which is everything you've ever dealt with in your life, and then there's imaginary numbers, which you'll get to much, much later in math. So real numbers, as we've talked about before, are basically numbers from everyday experience. They're positive numbers. They're negative numbers. They're decimals, like 3.2. That's a real number. They're fractions, like negative 1/5 or positive 3/4. All of those numbers from everyday experience on the number line, positive, negative, decimals, fractions, everything, they're all real. So when we talk about the properties of real numbers, we're basically talking about every number you've ever really used up till now in your math training. And they're called real numbers because later on you'll learn there's something called an imaginary number that's in a different class by itself. So we'll talk about those things much later. So here we're going to talk about some properties of these numbers. Most of these properties are going to seem like common sense. Right? But that's good because that means that you'll have a good, warm, fuzzy understanding of what I'm talking about. But I guess what I'm trying to prepare you for is some of these things I'm going to write down. They're going to look complicated. They're going to look, wow, why would they ever teach me this? But then you'll understand that it makes total sense, and this is something that you can realize that you kind of already knew to begin with. So let's talk about these properties. One class of these properties of real numbers is called the closure properties. All right, the closure properties of real numbers. And to set that up, basically we're going to have two numbers. And since we're kind of doing this general talking about the properties of numbers, we're going to have two numbers that we're going to talk about. In this case, we'll call them A and B. And A and B can be any real numbers. A and B could be positive 1. B could be negative 1/9. A could be 3.2. B could be negative 0.5. It doesn't matter, but they're two numbers that are real. So we'll just say that A and B are real numbers. Then, if A and B are real, the closure properties state the following. And let me switch colors just to kind of break it up a little bit. The following thing. Then, A plus B, so if you take the number A and add it to the number of B, what do you get? A real number, right? So this is a property. This is one of the properties called a closure property. All it means is if you have two numbers that are real and you add them together, the answer you get is also going to be real. And guys, this is not complicated. This is what you already know from math. I mean, this is basically saying that if you know 1 plus 3 is equal to 4, 1 is a real number, 3 is a real number. If they're both real, you add them together, you're going to get another number that's real. Similarly, A minus B is real. That makes sense if you subtract the numbers. If you take A and multiply it by B, you get a real number. Remember, when you have two things sitting right next to one another with no symbol, it means multiplication. And if you take A and you divide it by B, you're going to get a real number. Now, I think you can probably see now what I was talking about where I said a lot of these properties are common sense. All this is literally saying is that if you have two numbers and you take the first one and you divide by the second one, the answer you get is going to be another real number. And remember, real numbers are any number that's positive, negative, fraction, decimal, or integer. Doesn't matter. So it's basically saying pretty common sense stuff. You take two numbers and multiply them together, you're going to get a real number, right? As long as A and B are real to begin with, which is what we specified. So you might say, why do we learn this stuff? This is common sense. It's because you have to remember in math, you write down your absolute truths and you incrementally build your knowledge. So somewhere a long time ago, somebody proved the theory of real numbers and said, this is fact, okay? And then from that, you can do things like solve equations. We take this stuff for granted, but until you prove that it's true, you don't really know if it's legal to to solve equations by the methods that we're going to use pretty soon, you'll find out solving equations is not a big deal. But I guess what I'm trying to say is the groundwork is laid here for us to go and apply it to things like equations and inequalities and things like that. So even though they look a little silly, this is something that's important to write down so that we can build our bedrock and build our knowledge. All right, so let's go ahead and look at another class of properties, another important class. The next important class is called the commutative property. Commutative property. And again, what it's basically saying, this is going to be true of all of these things, but I'll write it down one more time. If a and b are both real numbers to begin with, then the following is true. If I take a plus b, it's the same thing as b plus a. And this is so incredibly ingrained in us from kids, it doesn't even make sense that it would be anything other than this. See, a lot of people will see this in a textbook. Commutative property, big word, must be scary. Of course it's not scary. Commutative property, and then a plus b is b plus a, and they look at this kind of thing and they say, what are they talking about here? This is saying nothing more than 1 plus 3 is equal to 3 plus 1. Would you all agree this is true? Well, of course this is true. It just basically says that for addition, it doesn't matter the order in which you add them. 1 plus 10, same as 10 plus 1. But you know, we take it for granted, but somewhere somebody had to sit down and prove it from fundamental mathematical, principles, and then come up with these things that we know now to be universally true. So this is how it's written in a textbook. This is what it means in real life, right? We also know that a times b is the same as b times a. This is multiplication, right? So this would be like, 10 times 2, of course you get 20, is the same as 2 times 10. When we learned our multiplication tables a long time ago, you have to think back to, third grade or whatever it was when you learn your multiplication tables. You learn that 6 times 2 is the same as 2 times 6. You started to see those patterns and realize that it didn't matter the order in which you multiplied. You kind of have to take yourself back to third grade to realize that there was once a time when you didn't know that was true. You figured it out by learning your multiplication tables. This is really called the commutative property of multiplication here, and this is the commutative property of addition. Basically, it means that no matter what the order is, you're going to get the same answer. Notice there is no commutative property of division, for instance, because that is not commutative. If you take, for instance, let me ask you a question, 3 divided by 4. Is that the same thing, I'll put a question mark, as 4 divided by 3? Well, of course not. These are not the same thing. 3 divided by 4 is a fraction, 0.75 or 3/4. And 4 divided by 3 is actually larger than 1. So these two things are completely not the same. So the commutative property does not apply to division. The commutative property only applies to addition and multiplication. All right, so let's go on to the next guy. This is probably one you've heard of before. It's called the associative property. The associative property. All right, so let's go figure out what this is. Again, a and b is real, so I'll just write this down again. A and b are real. This is basically true of all of these properties we're writing down. We're just kind of stating the obvious a little bit because we're not talking about imaginary numbers in this class at all. If you have something like this, a plus b in parentheses, and then you add to that c, that is the same thing as a plus b plus c. Now again, you look at something like this in a textbook and students get worried because they see associative property, which is complicated sounding, and then you have all this stuff with parentheses, and especially if you're not comfortable with parentheses, it just looks like gobbledygook. But don't forget what this is really saying. When we see an expression with parentheses, this parentheses means that we have to do what's inside first, right? And then after we do what's inside first, like if we had 3 plus 4 in here, we'd have to do the 3 plus 4 first. After we get this answer, we add whatever c is. Let's say c is 10. We'd add 10 to the result. What this is saying is, if we do a plus b first and then add c, where these are all numbers, right? You're going to get the same answer as what you get on this side. Now notice the parentheses are over here. This means you do b plus c first, get an answer, and then add the result to A. So what this is saying is basically, it doesn't matter the order in which you do addition. That's basically what the associative property says. If I have 1, 2, and 3 here, and 1, 2, and 3 here, it doesn't matter if I do 1 plus 2 and then add 3, you're going to get the same answer as if you're over here, you have 2 plus 3 for B and C, and then you get that result and you add it to A, which is 1. So if you have 3 numbers, in other words, 1, 2, and 3, you can add them in any order you want. You're going to get the same answer. This is, again, something we know is true. 1 plus 2 plus 3 is the same as 3 plus 2 plus 1. That's what the associative property is saying. So it's saying the order doesn't matter in the addition of things, right? That's what basically is going on here. What else do we know? We also have another associative property, and that one's going to be A times B times C, right? Of course, you have some of them inside parentheses. This is exactly the same as A times B times C. Now, notice the way I've grouped the parentheses. In this case here, we're doing A times B first, and then we're taking the result and multiplying by C. And we're saying that's the same as if you take B times C first and get the result and then multiply it times A. So it's saying the order does not matter for this. And you can, for multiplication or addition, basically. So you can prove that to yourself by picking some numbers, right? Let's pick 1, 2, and 3 for A, B, and C. So what this is saying is, we'll just do it right underneath. We'll say A is equal to 1, B is equal to 2, and C is equal to 3. And we're trying to say, is this equal to, if A is equal to 1, B is equal to 2, and C is equal to, we'll put a 3 here. Are these two things the same? Well, over here, 1 times 2 is 2 times 3. And over here, 2 times 3 is 6. That's what we have to do first. We have to do inside the parentheses first in both of these cases. That's what we're doing here. 2 times 3 is, of course, 6. And we get 6 on the right-hand side, so we're getting the same answer. So the associative property is all about the order. The associative property is saying that for addition and multiplication, you can do them in any order and you're going to get the same answer. This is not true of subtraction and division. If you get 3 numbers and you start subtracting them in different order, you're going to get different numbers because you might get a positive number for one answer and a negative number for another answer. Grab a sheet of paper and try it for yourself. If you take 3 numbers and subtract them in a certain order and then flip around the order and subtract them again, you're not going to get the same answer in general. All right? So far we've done the closure properties, which are up here, the commutative property here, and the associative property of course, addition and multiplication. And what we're going to do next is talk about basically the last real property that we're going to have. That's called the distributive property. And I have to pause for a second and tell you that the distributive property, in my opinion, is the most important one that we're going to talk about. Mostly, I mean, these are important, but most of these are kind of common sense, things that you picked up over the years anyway. We've given some examples to show you that. The distributive property is probably something you haven't seen until you really get into algebra or pre-algebra or something like that. But it is one of the most important ones because it's one of the properties that you'll use constantly from here on out. In fact, I'm going to say you'll probably use the distributive property in every single lesson from probably here to the end of the class. It's just so incredibly common. So let's write that down and talk about what the distributive property is. So distributive property. Okay, and basically what we're saying again is, A and B are real, so on. And what you have is the following. If you have A, parentheses, let's do B plus C, then what this is saying is this is exactly the same as A times B plus A times C. That's what this is saying. Notice that the right-hand side doesn't look anything like the left-hand side. It's kind of different than all of these other ones that we've done over here where we're kind of just mixing the order. This doesn't have anything to do with the order. This is really a property that's telling you that the left-hand side is exactly equivalent to the right-hand side. In other words, you need to start conditioning yourself in algebra from this point on, really. If you see parentheses here with different terms added together with something sitting out in front, like some number or some variable, then you need to get in the habit of pretending that you're basically taking the outside guy and multiplying him times B, that gives you this, and you take the outside guy and multiply it by c and get this term. So this is this times this plus this times this. You're taking the outside and you're kind of multiplying, because this is multiplication right here, but you have two things inside, so you have to multiply by both things, right? So let me show you this distributive property. It holds for anything, for variables, for numbers, for fractions. I mean, it's always true. That's why it's so important. And so let's give a quick example and try to show you that. Let's say let's pick a different one. Let's say A is equal to 2, B is equal to 1, and C is equal to 3. So if we plug things into the left-hand side, we're going to have 2 times B is 1 plus C is 3. Okay? Now, if we kind of put an equal sign here and a question mark, then what are we going to have on the right-hand side? If we distribute this in over here, 2 times 1 plus 2 times 3. Notice this is exactly what we've written here. It's A times B here, and then it's A times C right here. All I did was I take the 2, multiply by 1, give me this, 2, multiply by 3, give me that. So we're trying to ask ourselves, are these things really equal? So working on the left-hand side, we do what's inside the parentheses first. So it's 2 times 4. Put a question mark here. 2 times 1 is 2. 2 times 3 is 6. 2 times 4 on the left-hand side is 8. 2 plus 6 is 8. So it checks out. So you get the same thing on the left as you do on the right. So no matter what values of A, B, and C you pick, this identity here, this distributive property, is always true. It could be negative numbers. You know, A could be -5. You could have decimals. You could have fractions. You could have 0. It doesn't matter. When you have something sitting out of a parentheses like that, you always kind of distribute. That's what it's called, distributing. If you're, you know, in a group of people and you're distributing pumpkins out, or you're distributing pencils out, you're kind of handing them out to everybody there. That's what you're doing. That's why it's called distributive property. You're taking the A and you're distributing it into the inside terms and multiplying them like that. It's so important. That's why I'm harping on it, because when we get to, you know, future sections, you're going to use this all the time, distributive property, much more than these other properties on the board. So make sure you truly understand what we're writing here. All right, so let me go ahead and draw a little divider. And I want to talk about a couple more things before we work problems. We're going to get a lot of practice with this stuff. I want to talk about identities, all right? In specific, I'm going to talk about additive identities and multiplicative identities. And they sound really complicated, but you'll find out in a minute they're not complicated. An additive identity is a number such that when you add it to another number, you get the original number back. That's in words what it is. But in practice, you'll see that it's super simple. So let me write this down. Let's call it the additive identity. And I'll tell you right now, the additive identity for numbers is basically 0. The additive identity number is always 0. What does this mean? This means that if I take a number 3, could be anything, number 5, number 10, whatever, and I'm trying to find out what number can I add to 3 that's going to give me my original number back, right? Well, the only number that can go in here is 0. So 0 is the additive identity. If I take 5 and I add to it 0, I'm going to get the original number back. If I take 17 and add 0 to it, I'm just going to get the 17 back. In other words, the additive identity, it's a little bit of a silly definition. I'm just kind of teaching you this in case you see it on a test. The additive identity is just a number that you can add to any number you want, and you're just going to retain and get the original number back. That's why it's called the additive identity, because you get the identical number back, right? So again, some of these are mathematical definitions that look a little silly, but you know, mathematicians, they define them. We have to know what they are. So let's look at the multiplicative or the multiply identity. So now we're looking for a number so that I can multiply it by whatever number I want and still retain that number. For multiplication, the multiplicative identity is always equal to 1. The reason is I can take anything I want, 2, and if I want to get 2 as an answer, the only number I can put in here is 1. That's the multiplicative identity. If I have some variable a, and I want to get a back, the only thing I can do is multiply by 1 to give me a back. And again, so these are the additive identities and the multiplicative identities, and they're a little bit silly, to be honest with you, but all you have to remember is the additive identity is 0. It's just the number, the special number that you can add to any number you want, and you're just going to keep the original number. The multiplicative identity is that special number, which is a number 1, that you can multiply by any number you want, and you're just going to retain the identical number that you started with. The identity is why it's called identical. I'm trying to give you ways to remember this here. So these are things you might be asked on a test. Somebody might say, hey, what's the multiplicative identity in general? And you might say, well, that's 1. Well, what's the additive identity? That's 0. And so now you know what they are, you won't get them confused. All right, so what we want to do next is we want to talk about inverses. Inverses. Let me give you a little bit of a hint that's going to help you in algebra a lot. The inverse, first let me ask you, what do you think the word inverse means, right? I mean, a lot of people have their own definition, but you know, in general, most people would probably say the inverse of something is kind of like the opposite, right? It's like the opposite of what's going on, the inverse of it, okay? That's basically true. So if I asked you, what do you think the inverse or the opposite of addition would be? Well, you'd think about it and say, well, the opposite of addition is probably subtraction. And if I said, hey, what's the opposite of multiplication? You'd probably say, well, division is the opposite of multiplication. And you would be right. So these are the inverses that I'm talking about. The inverse of addition is subtraction. And the inverse of multiplication is division. And I'm not going to write them down, but the inverse of division is then multiplication, and the inverse of subtraction is then addition. Basically, it's just the opposite mathematical thing. And you might say, why are we learning opposites here? Why is that even important? Well, let me give you a quick example. And we're getting a little bit ahead of ourselves, but take a look at this for me. Let's look at the equation. A plus 1 is equal to 2. And to be honest with you, I haven't even really covered equations yet, but I feel comfortable in showing you this here because we're going to cover equations in the very next section. This is an equation. It's got an equal sign. That makes it an equation. You have a variable here. This is the variable a. A can be any number. I don't know what a is. I have no idea. Now, this isn't a simple equation. So what I want to do, though, is I want to figure out what a is. It's like the mystery. It's like a is inside of a package, and I need to unwrap the package and figure out what a actually is. I don't know ahead of time. You know, this is a simple problem, but in real life, I might be solving for the speed of a train. You know, I might have the wind speed pushing on the train, and I might have the engine force pushing on the train, and I might know how massive the train is. And I need to calculate the speed of that train going down the tracks, but I don't know what that is ahead of time. That's unknown. So I have equations and everything else that talks about the speed of the wind, and it talks about the friction on the tracks, and I have equations that talk about the power of the engine, and I can put all this stuff together and figure out what the unknown is, which is, in this case, the speed of the train. All right? So in this case, it's just much, much simpler than that. I have an equation with an unknown variable, but I want to figure out what it is. Now, I think you could probably figure out, by looking at this, what number does a have to be? Well, if a plus 1 has got to be 2, then a has to be 1. There's only one number that's going to work in here. 1 plus 1 is 2. A has to be equal to 1. We know this. But you got to remember that this equation is super simple. Most equations are going to be more complicated. You're not going to be able to look at them and figure out the answer by looking at them. So we need to figure out a way to actually solve for this thing and have it work for every equation. So what we do is we apply the inverse. What we have here is a plus 1 on the left. So this is addition here on the left. So we want to do the inverse of addition to get rid of this 1, because if we can get rid of this 1 and kind of make it disappear, then we will have a on the left-hand side by itself. So what we do is we do the opposite of addition. We do subtraction. So we say a plus 1, and on the left-hand side we subtract 1, because that's the inverse of this addition happening here. And if we do it on the left-hand side, then we have to subtract 1 on the right-hand side. We're going to talk more about this in the next lesson, but basically, whatever you do to the left-hand side of the equation, you have to do it to the right-hand side of the equation. It's just, that's the rules of the game. It's like baseball, there's rules. Algebra, there's rules. If you do something to the left, you have to do it to the right, otherwise you've made a mistake. So, if we subtract a 1 on the left-hand side, we must subtract 1 on the right-hand side. All right? And so on the left-hand side, we have plus 1 minus 1. So these things give us 0 here, right here. So on the left, all you really have left is a. And on the right-hand side, 2 minus 1 is 1. So you've solved this equation. You've basically put a by itself. And you now know that a is equal to 1. And the reason I'm bringing this up is because a lot of books, they talk about inverses of addition and subtraction. And students have no idea why that's useful. You read about it and like, okay, great, it's inverse, wonderful. But it doesn't tell you why it's important. It's important because you're going to use this fact when you solve equations, which is the next thing we're going to talk about. So when you see addition in a problem and you're trying to get the variable by himself to solve it, then you have to do the inverse or the opposite, which is subtraction. If you see subtraction in a problem and you want to get rid of it, you need to do addition. That's the inverse of subtraction. If you see multiplication in a problem, you're probably going to use division to get rid of it. And if you see division in a problem, you're probably going to use multiplication to get rid of it, which is the inverse of that guy. So make sure you understand that. They're basically opposites that you kind of knew about already, but in math, everything has a special term. It's called an inverse. The inverse of addition is subtraction. Inverse of multiplication is division. So now what we're going to do is we've really reviewed all the properties that we're going to review. We've got these closure properties, which are very simple. We've talked about those. Commutative means you can flip the order of addition or multiplication as far as being backwards or forwards. Associative means if you have 3 numbers going on, it doesn't matter the order in which you do the operation for addition and multiplication. Distributive is so important, you just take whatever's on the outside and you continue multiplying times the inside terms. And then these identities we talked about for addition and multiplication, and then the inverse, which is the opposite of addition and subtraction and things like that. So we've covered a great amount.